our final presentation, getting ready to go.
Everyone hates me.
No, nobody's gonna hate you here. Hate is a very terrible word. So back to the fundamentals. Are you actually monitoring your cloud? Mohamed, thank you for being here.
So hello everyone, my name is just telling him that basically everyone probably hates me right now because it's last presentation. I'm keeping everyone around. So my name is Mohamed Elsakhawy. Today we'll be talking about basically the fundamentals of monitoring OpenStack on-prem cloud. So the agenda we have for today is what is basically monitoring, what monitoring actually fails you. So basically when you have an issue and basically monitoring doesn't tell you that you had this issue. We'll look then how everyone is monitoring the cloud right now, the ad hoc solutions, the standardized solutions, and the commercial solutions as well. So we'll be very high level for that. And then we will look at what's so special about monitoring an on-prem cloud. What are the metrics that make the cloud very weird or hard to monitor? And what should you monitor? So the basic things that you have to keep track of to be able to troubleshoot issues. And then we'll look at finally the pain points. It was supposed to be having a short demo of Zabbix, but I'll substitute that with some presentation on the Zabbix itself. So first, what is monitoring? We're basically about collecting data that helps us to detect issues within our environment and be able to scale it in the future based on this information. So we're able to investigate issues and predict issues when they occur. We're not collecting everything for that. So we're only collecting the data that we need to be able to look at issues and investigate them. We're not collecting data that's not useful for us. One of the very common examples of that, basically, if you have BMC or ILO in your environment, you don't really care about the CPU or the memory utilization on a BMC board itself. We're collecting and keeping this data. So basically, we want to make sure that in the future, we're able to look back at it and see the trends that happened at that time. Alerting is not fundamentally part of monitoring. However, it's very useful if you have it. When you don't have it, you basically have issues and you're not alerted or told about it. Some common tools that are used for monitoring in general are Zabbix, Prometheus, Grafana, Nagios. All of these tools are in the open source / free source realm. And there's also the commercial platforms as well, if someone is familiar with the WhatsApp monitoring solution. For logs, or keeping track of logs, we have Grafana Loki, Openstack, and FluentD. Many set of tools that basically track your logs for you. So when we're looking at what should be collected, there's three main pillars for observability, which are metrics, which are basically tell you the data that's accessible in your cloud when it comes to CPU, CPU, service stats, memory, and so on. So it's not basically the services in your environment, mostly the items that you need to monitor. There's many tools that actually allow you to do the monitoring for that, such as Node Exporter, Zabbix Agent, Nagios, and so on. And logs. Logs traditionally has been used as aggregated logs, and we basically have an RSys log server running somewhere. This is not the case anymore. Logs are now being heavily utilized for monitoring your environment. So we're looking at collecting and transforming the logs from all your services and being able to collect these and monitor on these as well. You have to store them and aggregate them. So the collection and transform, there's many tools that allow you to do that, such as Logstash and FluentD. And when it comes to storing and aggregating as well, there is Grafana Loki and Openstack, the Elasticsearch, Logstash, and Kibana, which is a visualizing platform for that. Traces are outside the scope of this presentation today, but basically they allow you to trace a request that comes into your system from start to finish. So you basically see the flow, what system parts are interacted with to get you the solution or the actual answer for your request. Oh, this was fast. So basically, if we're only focusing on metrics and logs, we're looking at the operating system and being able to use some sort of agent to collect the CPU, the memory, and the service stats on it. And the logs, we have some sort of log transformation tool, such as Logstash or FluentD, and collects it to a certain log aggregation utility. So when does monitoring fail you? I'm sure many of us operate OpenStack clouds in here, and the idea of having an issue being told by a client that you're having an issue is pretty embarrassing. So one problem is basically if you have an issue, you don't know, you know actually what's occurred, but you haven't heard about it. You were only told about your customer that the VM is down or the application is down. And with that comes the alerting part of it. What is the priority basically on such alerting when issue occurs? Or worse even, which is you know that basically there is an issue, but you don't know why it occurred. So it's there. You know that your VM basically has performed badly, or the Ceph environment is slow, but you haven't collected the OSD metrics on any of the disks. Basically. So a big issue with that is, how do you know what caused this issue or caused the slowness? And it comes back to the question, should we collect everything or not? So monitoring basically allows you to detect an anomaly within your environment, but it doesn't specifically allow you to get the cause. So when you're focusing on specifying what metrics to collect, you need to be focusing also on which metrics you need to collect to get the cause, not only the anomaly. And then to be able to put measures to prevent this anomaly from happening. So this probably is the most important slide here. So how is everyone basically monitoring the cloud? The very common approach, which I've seen over the years, is basically the ad hoc solutions. You inherit an environment, you have some sort of monitoring solution for it. So what you do is basically you collect your stats from scripts or different API tools, REST APIs, and then you plot that into your monitoring solution. So please don't do that. There is many solutions out there right now that actually allow you to monitor the cloud properly in a more standardized way. There's open source solutions, and this is basically the realm where there's many people have made their own settings in that. So there's Monasca. Cola Ansible did support it. However, unfortunately, Monasca is inactive since 2024, with one release. There's obviously Zabbix. I'm a big advocate for Zabbix. I think it's a very smooth to scale. It's very well designed to allow you to monitor hybrid clouds. And it can allow you to add templates and ad hoc solutions on top of it. So even if the template is not good enough for you, you can actually add something that fits your own environment. Grafana and Prometheus are also some of the very common solutions that are being used. Prometheus has an exporter specifically for OpenStack. So you could use it to deploy it on your controller node. It will collect the data, and then you'll be able to plot it within Grafana and set alerts on that. For logs, the very common solutions I've seen are basically Loki and Elkstack. Elk comes by default with Cola Ansible using Fluentd. And there's also commercial solutions as well, such as IBM and Astana, and Datadog monitoring solutions. All of these are a bit pricey to basically use. So I've seen many people going in the Zabbix and Grafana plus Prometheus realm. So what is so special about monitoring basically on-prem clouds? Why don't we use just regular Zabbix and template and everything is happy and we don't have issues? The problem with the cloud is basically you have many services. They are very interconnected. And having a server that's up is not sufficient to tell that the cloud's operating as expected. So you have to think of a VM that actually needs network access. For that VM to operate, it has to have a good QEMU KVM process, basically memory and CPU and processes on the host. You have to be able to get an IP for that VM. So you have to have the OVN, OVS on the host, Linux Bridge if you're using that, plus the agents actually that provide you the IPs. So you're looking at also no DHCP agent. If there's no DHCP agent for your network, the VMs, and this is basically catastrophic. All the VMs on that network will lose their IP at the next lease expiry. If there's no router or the routers are scheduled as active, they are running an HA mode, and everything has multiple basically active instances, you run into issues with that. So all of these have to be monitored to make sure that a single VM has access to a network. Or if basically the very common thing is VM is slow. So if a VM is slow, we're telling you that the VM is slow with disk operations, the customer is telling you that. There's many pieces actually that you have to monitor to make sure that this is operating as expected. So is it Ceph? Are you monitoring Ceph? Is it the network? So network, the compute nodes or even the routers? Is it the VM itself? The QEMU process is overstarved for resources. So there's many tiers for the cloud. Each one of them has to be monitored properly to make sure that you can actually tell why issues happen. This becomes even worse when you're looking at federated and hybrid clouds. If you have a multi-region cloud, so how do you monitor compute hosts in a different network that's basically staggered or thrown in a different data center that you don't have access to for your monitoring solution? Or even if you have an AWS, GCP, plus your own OpenStack cloud, how do you keep that in a single monitoring solution? And basically also the hybrid metrics aspect. So this will basically be the fundamental things that you have to keep track of your environment to be able to tell that this cloud is operating normally to a certain, I would say to the most extent. The first is looking at the backend services. So if you're running OpenStack Cloud, you'll be looking at RabbitMQ, MariaDB, and so on. And then you'll be looking at the OpenStack services, such as Nova, Neutron, Cinder, and whatever, and you have to make sure that the API endpoints are operational, they have the right response times, and the right return values. But again, at this point, you just have a functional cloud. You don't have a functional VMs within the cloud. So next, we'll be looking at the network. You need to ensure that your routers are scheduled properly, all active passive mode. You can't just have active if you're running HA. Each network has to have its own DHCP and metadata agents available, or at least DHCP agents and metadata available have to be available for the entire environment. This would basically be talking about the quorum in the active passive solutions. So if you're running HA routers, you have to make sure that your router is scheduled properly. I've seen instances where basically routers are scheduled as active, so multiple active instances per particular router. And it has been actually very common that I see a network losing the DHCP agent. So stuff like that you need to keep an eye on, because if this happens, you were very susceptible to actually losing the entire IP assigned to your VMs. If you're running Octavia, you have also to keep an eye on the passive active stats of the Amphora node. If you're running Designate, you have to make sure that DNS actually is propagating properly, not just through the interface from OpenStack. If you're running, obviously, running storage, the performance of Ceph and NFS, you have to make sure you're monitoring this properly to be able to tell that this cloud is actually operating. It's providing the service for the VMs that we need to send and get data. So Zabbix. Zabbix is a very good solution. It's very scalable, very smooth to scale. So why Zabbix? Because basically out of the box, it's very easy to deploy. You can deploy a full Zabbix deployment within a day, having servers, proxies. It's very simple that it actually allows you to auto-register nodes whenever you basically spin up a Zabbix agent. It will connect directly. You can create an event that register this node, start the monitoring on it without any intervention. It allows them, has templates that basically allow you basic OS metrics, correlate metrics, even using triggers. So basically multiple metrics looking at the CPU, the memory, the Nova, basically response times. And you'll be able to tell from that how the health of the node is. It's agent-based. It allows you to have proxies that to reach unreachable networks. And this is extremely important if you have a multi-region cloud that you basically want one monitoring solution. You could deploy in each region a proxy, and that proxy will basically collect the data for you, push it to the Zabbix server, and becomes your entry point to that. You don't have to expose the entire environment or open the network all in between. You just have to open it for that particular proxy. It's also important if you using any kind of hybrid cloud, using the AWS, GCP, and OpenStack. Now this becomes your solution basically to that. It allows using MySQL and Postgres in the backend. Oracle used to be supported, but it's not anymore. So the architecture of Zabbix is pretty simple. It's modular in that regard. It's relatively lightweight when it comes to the agent. It has an overhead, but not that much of overhead to notice. The monitoring times for Zabbix, it's not as granular as many people would want, like millisecond aspect. It's usually in a second level. It's an agent-based. It has passive and active mode, and I'll explain that in a sec. Proxies are extremely important because they allow you access into a network that you wouldn't otherwise have from the Zabbix server. So this is basically a layout for a Zabbix deployment. We'll have a server on the top here, has access to a database, and proxies will be deployed in all of the regions for your cloud, or all data centers that you have. And those agents on the bottom will be reporting to the Zabbix proxy, and from there, the Zabbix proxy will be reporting the data to the Zabbix server. Zabbix server is where the configuration is stored and also acts in active-passive mode. So whether the Zabbix server will connect the proxy, give it the configs that the agents have to monitor on, or the other way around. And as I mentioned, the agent actually is active-passive mode configurable. So either the agent collects the data and pushes it directly to the server, or the server would basically initiate a pull connection to the agent, and will ask it to retrieve this and that, and then it will pull it back. There are majorly, I would say, three main concepts within Zabbix. The first one is an item. An item is basically the metric that you want to monitor for, such as CPU, memory, response time for a particular service. And this is what you want to collect and keep. A trigger is basically something that evaluates if the item value is meeting your criteria or not. So you can think of this as basically a response time of a Nova API. If you're getting a response time in 10 seconds, this is a problem. So you collect the item as 10 seconds, and then you evaluate whether or not it exceeds certain criteria in the trigger itself. And triggers create events. And based on those events, you can actually create an action. So this will basically be the flow of creating an item. You specify what to monitor. From that, you create a trigger to evaluate that. There's multiple aspects for the triggers when created, that the trigger can go back into a non-triggered state based on a different expression. So you could easily tell that if, let's say, my self response time is this particular IOPS, if this goes down, the trigger basically will reevaluate the expression. But you can specify a different expression to actually say that this is okay now. So it doesn't have to be going back to the same level. So you could basically aggregate multiple things to check before saying that everything's okay. So this is a very simple dashboard for Zabbix. This is actually from the Zabbix website itself. It's basically, those are the items we're plotting on the left-hand side. There is multiple visualization tools that you could actually use for that. This is a dashboard. Normally people, when they deploy a particular cloud, they have a dashboard that for each region or for each particular set of views you want to see. Sorry, here's. So Zabbix allows you to create templates, and you basically take this template and apply it to many hosts at the same time. So on the top here, you see basically I created a template called Openstack, and there is items, triggers, graphs, and dashboards, and so on in it. Basically, within that template, I create all the items I want to monitor and create all the triggers for those items. So basically, when something doesn't apply properly within that item, I can trigger something and create an event. So from that regard, it allows you to quickly spin up something to monitor many systems without any kind of ad hoc solution in it. It's basically standardized in that regard. When you look at a particular item, as I mentioned, basically there's multiple types of it. You can create an HTTP request, you can create SNMP, or even use Zabbix agent itself. Basically, this is the expression that you, sorry, the actual key. So this is what you collect. You can specify the number of processes, the CPU, the memory, and so on. And you can specify how often it's taken. So basically update interval for it, the collection, and how long to keep basically for that as well. One of the problems that you don't want actually is to keep the data forever. Zabbix tends to grow very heavily. Database, even for monitoring very small environments, can easily grow to 60, 70 gigs really fast. So triggers, basically, as I mentioned, triggers happen when your item meet certain criteria. So we specify an expression in a trigger, and in that expression, if it meets that criteria, the trigger starts creating events for it. As I mentioned here, so the OK event generation part of it. So basically, if we say that if the Nova API is exceeding 10 seconds, create something. So basically, the expression would say if it exceeds 10 seconds, create that. Our OK generation can use a totally different expression. So we basically say, yes, it has to go down back below 10 seconds, plus the Nova API has to have created an instance. So in that aspect, you could create actually multiple tiers where you verify something didn't just fail, basically failed, but actually got fixed, and something happened afterwards. And lastly, basically creating a new host is pretty simple in here. This is all, again, created events. You could just spin up Zabbix agent, it will connect, and then you can create an auto creation for the event that it registers that host, adds templates to it, and start monitoring stuff on it without even any intervention from you. You specify a host, you specify a template for it. It also has details for IPMI, so those familiar with IPMI could actually use that to monitor the host as well. So what are some pain points for monitoring cloud, basically, compared to regular hosts? The first is basically having hybrid clouds. So if you have a cloud that's in AWS, you have a cloud that's on-prem, or even if you have a cloud that's on-prem, but it has Ironic, it has Kubernetes, you have multiple technologies in it. How do you keep that in track? My experience is the best bet is to look at standardized solution rather than having ad hoc for everything. You could easily create a solution for that and license the products for everything. But having one solution, either Zabbix, Prometheus, or so on, but keeping track of the stuff in it and having your own team create monitors for that. A multi-region cloud is obviously a problem because if you don't have connection to those data centers, it's usually a problem. This is actually a very important part where we're basically correlating the cloud performance with the application performance. an aspect basically that when the user tells you that my site's slow or my application is slow or we're having issues with whatever technology, Kubernetes or whatever, how do you correlate that to your environment performance? And lastly, with legacy environments, when environments are using Xen or any kind of even bare metal Proxmox or stuff that's old, really old, Proxmox is still active and being used nowadays. When it comes to legacy environments that are actually very outdated, you need to look at this and how to maintain monitoring for them, but not maintain monitoring specifically based on them. You need to be able to look at forward, that we need to monitor going forward the cloud this way, and not base our solution for monitoring based on the legacy environment. That's basically it. Thank you for your time today. And if you have any questions.
Mohamed, thank you so much. We're going to take time for a couple questions.
So I'm Jonathan. I've never run Zabbix, but I've run. I've used Nagios, or been familiar with Nagios for 20 some years, and I've run CheckMK for about 15 years, 14 years. So CheckMK has a whole lot of automation that you can do right out of the box. And I was wondering if since you know Zabbix, have you run CheckMK, and how do you feel about what comparisons do you see?
So what I really like about Zabbix is ease to scale up. So basically, you can easily scale the environment with just having the proxy, but also the ability to auto-register and auto-add things without intervention. So your environment basically can go, if you're using any kind of provisioning method, for VMs or hosts, you can easily do that and get them automatic to register, start monitoring them without any intervention. But I haven't actually used.
Okay, so that's a good point. Yeah, I don't know if I can automatically add a host in CheckMK, but I can make it so that things like switch ports, if a device is added, it automatically gets added to the check state, to the inventory.
Yep. No, I don't agree.
Other questions?
So I was going to ask you, Mohamed, which is the best Canadian research cloud, but instead of asking you that,
Okay. Good answer.
So a lot of folks are moving towards the Prometheus Grafana stack these days, and Kubernetes, of course, has driven that a bit. I'm curious your thoughts on why one or the other, and maybe what pushes you in the direction of Zabbix for that.
Well, I think for Openstack clouds, the exporters for Prometheus and Grafana are actually good. The scalability part is much easier within Zabbix. That's what I found within deployments. Also, the alerting part and the levels of alerting are much more granular within Zabbix than Prometheus.
Awesome, thanks.
Yeah, Josh.
What about OpenTelemetry ingestion?
Sorry, say it again.
OpenTelemetry?
Yes, but OpenTelemetry, it's mostly, at least, I can answer this from, okay, let me rephrase that. Being able to look at the telemetry of an environment does not automatically specify the tool that you use to basically monitor it. So I would say Zabbix and Zabbix, Prometheus, Grafana mostly look at the tool aspect of it, but not about the actual items. So for the clouds, I think there is lots of things with Ceilometer specifically on what to collect, for VMs and such. But for the backend services, I think there is way vagueness when it comes to that, specifically about how to tell that it's healthy environment. One of the issues I've heard people basically saying that we disabled HA routers specifically because they're not working properly. So there's lots of pieces within OpenStack that actually make OpenStack operational, but still your VMs are not getting the actual path to network. You're not getting the right performance, or not getting even IPs when they start. So that would be basically looking more at the monitoring aspect of it. What makes the cloud safe to spin up VMs in it? If that makes any sense.
Anybody else? Anybody else? Mohamed, thank you so much.
Thank you.